Hello and welcome to another Reigate Maths video. I'm Simon, and in this video we're going to be looking at the Functions and Mappings unit from the second year of the A-Level Maths content. In this video we're going to be focusing specifically on the modulus function and looking at an introduction and a little bit of how to sketch functions. In a second video we're going to look at how to solve equations and inequalities and also look at this as a transformation. So what is the modulus function? Well, first off, let's have a look at some notation. The notation is effectively this. A number with two lines on it. Sometimes it's known as the absolute value. And on your calculators, you have a button for abs, which will do this for you. But what is this function doing really? Well, let's have a think about a number line. So I've got this number line here. What does this function do? Well, the absolute value, you can think about it as the length of a line or the distance a number is from 0. So if we think about the number 3, we can see that 3 is 3 units above 0. What this means is the modulus of 3 is 3. But what about these negative numbers? Well, this number 2, the minus 2, is negative 2, but it is 2 units below 0. That's all that the minus does for us, is it tells us which direction we're going in. The modulus tells us the size of the number or how far away from the origin or from 0 it is. You may recognize this notation from vectors as the magnitude or size of a vector. It's the same idea as we're thinking about the size of a number. In a similar way, the minus 7 is 7 units away from the origin. The minus says it's below, so modulus of minus 7 is 7. So in general, what does this tell us? This tells us that the modulus of some number a is the same as the modulus of minus a, and that is just the value a. We see here that the modulus of 3 was 3, the modulus of minus 2 is 2, and the modulus of minus 7 is 7. Using this relationship, we could also do the same with minus 3, with 2, and with 7, and we get the same answer. So from a numerical point of view, all this does is remove the minus sign. It's a lot more technical than that, but from just a number point of view, that is what's going on. So let's have a look at some examples. In this first example, we're going to do some basic calculations. We've got this function here, f of x is the modulus of 2x minus 3, and then we add 1 to it. Now, I've written it like this. You may want to be careful when you're writing modulus signs out. As you can see, my modulus sign looks very similar to my number 1. If you want to make it really clear, what I would do is change your 1. Or write the modulus signs a bit bigger if you're particularly concerned. This is clear enough though. So how does this work? Well, what we're going to do is we're going to put 5 into the function, then add 1 to it. 2 times 5 is 10, minus 3 is 7. Get the modulus of 7 plus 1. Modulus of 7 is 7. This is 8. So a nice simple one. We didn't have to think too much, or we didn't have to worry about dealing with the modulus really. This next example, however, we do need to be careful. Pause the video and have a go at this yourself, and then we'll go through it. So, we can put in the same way, -2 into our function. But now, 2 times -2, -4, -3 is -7. So we get the modulus of -7 plus 1. Now we know, because we're doing the modulus of a function, the modulus of -7 is 7. And so we in fact get exactly the same answer as f of 5. This is not something necessarily we can guess. If once we get to drawing these graphs, we can see that a little bit more clearly. But for now, we're just getting used to calculating. So we've got this third example here, finding f of 1. Again, pause the video, quickly work it out yourselves, and then come back and I'll go through it. Like before, we put 1 into our function. 2 times 1 minus 3 is -1. Plus 1. See how I've written my 1 here slightly smaller, so it makes it clearly different from the modular signs. It's just being careful with your layout, but generally the examiner will know the context of the question, will know what you're doing. Modulus of -1 is 1. So f of 1 comes out as 2. This is a really important idea because modulus functions are very, very useful if you're only interested in how big something is. So what we're going to do now is just start to have a look at the graphs of these functions. So here we've got the function y equals the modulus of x. So we're just going to start with the basic shape of this graph. So just so we can get an idea as to what's going on, we'll just work out some numbers and see what the graph, and then we can go from there to see what the graph looks like. So if x is 1, we're doing modulus of 1, so you get y as 1. Likewise, 2 gives us 2, and 3 gives us 3. So we can see when x is positive, y is the same number. So when x is greater than 0, which is these bits here, this graph looks like y equals x. So we get a straight line like that. 0 spits out 0, so same thing. But let's have a look at the minus numbers. So if x is -1, the modulus of -1 is 1, because remember, we take off the minus sign. Likewise, -2 and -3. So in this bit, when x is less than 0, we get that y is the minus of x. So we get a symmetrical straight line like that. This is the graph of y equals the modulus of x. Now, a couple of points. It is symmetrical. In this case, it's symmetrical about the y-axis. The gradient of this line is the same as the gradient of this line, but negative. In this case, they're both 1. But generally, if we've got the modulus of a linear function, the gradient of this part will be minus the gradient of this part. Other key point is when the modulus is around everything, so we've got nothing outside here, the entire graph is above the x-axis. So let's think about what happens with a different graph. Graph of y equals the modulus of x minus 1. Well, we're going to take these numbers and subtract 1 from it, which if we think about transformations, all that does is it takes this graph and moves it down 1. It crosses at minus 1 on the y-axis, 1 on the x-axis, and minus 1 on the x-axis. So don't just think, because there is a modulus there, that the entire graph is above the x-axis. If we start having numbers outside the modulus, we can go below. Let's look at a more complicated one to see a different way to approach this question. So we're going to sketch the graph of y equals modulus of 3x minus 2. Now, because the modulus is round everything here, we know this graph is not going to cross the x-axis. It's going to touch it, but not cross it. So we don't need to worry about drawing below. If the modulus was here instead, so modulus of 3x, then minus 2, that would be different. So let's think about this in a different way. Let's start by thinking about the graph of y equals 3x minus 2. Well, we know this is going to cross the y-axis at minus 2, and we can work out where this crossed the x-axis. In this case, it's at 2 over 3. So we can draw the graph. I'm going to extend this slightly. We can draw the graph of y equals 3x minus 2, and it's going to look something like this, where this is 2 over 3, and this is minus 2. Now let's think about what the modulus does. The modulus takes our answer and then makes it positive. So for here, for x is 1, our answer to 3x minus 2 is a positive number. So it's not going to worry about anything there. But when x is minus 1, our answer is a negative number. So it's going to take that and it's going to make it positive. And for every x value where the answer comes out as negative, it's going to swap it to positive. So what we can do is we can go, okay, everything that's below, whoops, and we've got to try and get it as symmetrical as possible, which I am not managing to do there. So I'm just going to cheat a little bit. So we're going to get it as looking something like this. So we take everything that was below the x-axis and make it positive. The annoying thing about this is then you have to erase everything that was below the x-axis, because that's not actually part of the graph. It crossed the x-axis, sorry, the y-axis originally at minus 2. We make that a positive number, so that becomes 2. this is the graph of y equals modulus 3x minus 2. Now, interestingly, and this is really useful to think about when trying to sketch graphs, we're trying to solve equations, is this bit from 2 over 3 upwards, this is the graph of y equals 3x minus 2. From 2/3 below, this is actually the graph of y equals minus 3x plus 2. So we take everything that's inside and make it minus. That'll become very relevant in the second video when we look at solving equations and inequalities. That is an introduction to modulus functions and how to sketch them. Thank you for watching.